Results of 29th insider threats analysis presented in the annual Cybersecurity Insiders and Gurukul report show that insiders attacks increased by 68% in 12 months, and only 48% of institutions survived are confident in protecting their information from insider threats. The same report states that to counter insider threats, only 49% of institutions choose the tactic of training the institution information and telecommunication users, and also training the individual. Therefore, this study is aimed at solving the scientific and practical problem of assessing the impact of staff competence on the state information security of the institution. Purpose of the study is to develop a method for assessing the impact of staff competence on information security of the institution using a structural and functional approach to description of staff competence. Competence in this scientific and practical research should be understood as a set of knowledge and skills as well as personality traits, the use of which allows the individual to solve a problem of scientific. The competence of an individual functionally depends on the knowledge, skills, and personality trait. If we introduce the coefficient of importance of knowledge, skills, and personality trait, the competence of the individual will be shown as ratio, as can you see at this slide. At the next assessment of the level of knowledge is obtained by testing. To assess the level of knowledge tested by the result of test task, a mathematical model was used, which includes 5 steps. First step is the calculation of the complexity of the test. The complexity of the test is characterized the number of tests of different complexity, and determines the maximum score can be obtained by the test subject provided all the correct answer to the task test. Step 2, calculation of the quality of the answer. The quality of the answer is a continuous random variable distributed on the interval 0 to 1, which characterizes completeness on the correct answer. Step 3, calculation of the probability of the correction answer. The probability of the correct answer is determined by this ratio, which can you see at this slide. Step 4, calculation of the answer level. And step 5, calculation of share of correct answer. The share of correct answer is a continuous random variable distributed on the interval 0 to 1, which characterizes the level of knowledge based on the quality of answer obtained to tests of different levels of complexity. Assessment of skill level is based on the result of a specially designed set of practical tasks. Assessment of character, personal qualities, is calculated as the number of correctly completed practical tasks to the total number of practical tasks. For each position in the institution, the required list of character traits consists of XS of elements. The importance of each character trait is determined by a weighting factor BI. Then the following criteria should determine by the ratio, which can you see at this slide. By information security of institution, in this study, we will understand the state of the institution information protection from many information threats, which is determined by the institution information threat model. The dependence of information security of information threats is presented on this expression. To find the quantitative value probability we used the method of calculating the probability of realization of information threat from an internal violator. According to this method, the expression for calculating the probability of the occurrence of the threat of information from the set of threat information from the employee or institute is on this slide. Next, you are offered the result of modeling the dependence of information security of the organization on the level of the staff competence. In this slide, you can see a variant of the internal violator model. According to this model, employer position are given, and the probability of threat from this position is calculated also. At this slide, show the model threats to the information of the institution. According to this model, I'm sorry, but this slide. According to this model, was identified 9 types of information threats, and also probability of these information threats are also calculated. At this slide, the probability of information threats from some institution was calculated, and this table shows the result of a multiplying of the probabilities from previous 2 tables. And this slide shows the value of staff competence for 3 examples. Using the model threats to the information of the institution and the internal violator model, obtained a quantitative value of information security. So the mathematical models take into account the complexity of the task, and the result of the experiment indicates that with the increase in the level of competence of employees of the institution, the state information security in the institution increases. The methods of assessing the influence of personal competence on institutional information security allows obtaining a quantitative value of information security. The proposed method makes it possible to automate the process for evaluating the competence of personnel by using the mathematical apparatus of modern testing theory, system analysis, and probability theory. Practical orientation of research consists in the use of the developed methodology in the information security service at the institution to assess the possibility of implementing the relevant type of threat from the institution personnel, taking into account the level of competence of the personnel. The method for assessing the impact of personal competence on the information security of the institution make it possible to assess information security, taking into account the model of the violator, the model of information threats, which are designed for a particular institution. The report concludes. Thank you for your attention.
Thank you, Oleg. Dear colleagues, we have 2 minutes for questions. One question, please.
Do you try to set up an optimization task basis on your model?
Optimization task, I think the optimization, this method is the calculated level of knowledge of the personnel of institute. If I'm sorry, зараз. The result in Ukrainian. Якщо українською, то оптимізація здесь то, що Оптимізаційна задача полягає в тому, що ми знаходимо десь оптимальний рівень знань, компетенцій працівників та його вплив на інформаційну безпеку установи взагалі. Дана модель і математичний апарат дозволяють розрахувати чисельний рівень саме інформаційної безпеки, який буде у нас знаходитися в межах від 0 до 1. Ну і звісно, якщо більше к 1, то краще, ближче до 0, то гірше.
Dear colleagues, excuse me, please try to answer in English because we have a lot of foreigners within our section. So if you have some problems with English, try to speak in English simpler. Okay, thank you. We have more clear questions.
May I ask you one question?
Yes, Thomas, please.
You demonstrated 3 experiments. Are there 3 real institutions? And if so, how much members of staff were included?
No, on example, I demonstrate variant of institute. It's abstractive model. For the each institute, we can use, or we can do our models.
Okay, thank you.
Okay, thank you. Let's move on. The next speaker is Oleg Bisikala and his team. Please, who will make report?
I am Vyacheslav Kovtun.
Hello, Vyacheslav. Nice to meet you.
Hello.
Please start.
Good day, dear colleagues. I am Vyacheslav Kovtun, and I am glad to introduce to you the results of the research named Precision Automated Phonetic Analysis of Speech Signals for Information Technology of Text-Dependent Identification of a Person by Voice. Phonemes form the basic level of language description and determine its information and communicative characteristics. It is confirmed in particular by the method of forming speech corpora, in which phonograms of speech signals are accompanied by their transcriptions, which is nothing more than a sequence of phonemes. However, like a physiological process, speech is characterized by a considerable variability, so there are a great number of options for phoneme sounding. This circumstance explains the fact that no any theoretical and software complex has been created yet for the effective automatic phonetic analysis of coherent speech, although its necessity is extremely urgent. The mechanism of automated phonetic analysis is an obligatory structural unit for information technology focused on solving such a fundamental and applied phonetic problems as, for example, sounds recognition, the study of suprasegmental linguistic characteristics, speech synthesis, etc. As it was noted, the final solution of computer phonetic analysis has not been found yet, but its relevance encourages research teams to a creative search. The object of the research presented in the article is the process of clustering centered phonemes in the spectral representation of the speech signals which are studied. The subject of the study are the methods of acoustic theory of speech formation and information theory, the results of which will be generalized using the methods of probability theory and the mathematical statistics. The aim of the study is the analytical formalization of the process of phonetic analysis of a speech signal in the frequency and temporal spaces based on the functional functional of the relative entropy, oriented towards the use of the text-dependent voice authentication in information technology. Task of phonetic analysis of the speech signal represented in the set X can be reduced to the finding such a probability density from a certain set of alternatives PR, the difference of which from Px is minimal according to the selected metric mu. When studying speech signals in the frequency space, a characteristic parameter for estimating the desired differences from a set of alternatives PR is the set of values of power spectral density GR, where F is the upper limit of the frequency range of the empirical speech signal. Here we can see the generalization of the model of the phonetic analysis of speech signals in temporal and frequency spaces, which the center of the cluster of the Earth phoneme determined by the expression 1, it is possible to determine the optimal estimate of the power spectral density ZR for the phoneme of the basis of the expression 3. If such actions are implemented for all other phonemes of the studied language, then we obtain the phonetic acoustic database, the universality of which will increase with the increased number of the phonemes pronounced during the formation of the model, that is, the parameter J. Here we can see the analytical formalization of metrics for qualitative evaluation of the results of phonetic analysis of the studied language in the paradigm of the proposed model. The theoretical material presented in the previous slide has found its application in the analytical formalization of the metric mu, sigma, delta big, and delta small, focused on the qualitative evaluation of the results of phonetic analysis. The use of after-regressive analysis is deriving the functional of related entropy mu-r allows to determine the spectral characteristics of the center of the cluster of the ERSH phoneme. As a result of solving the optimization task by changing the order S of regressive models created to describe the studied speech signal. We can qualify the quality of the phonetic analysis performed in this way by calculating the value of the coefficient of variability sigma. Here we can see the analytical expression to calculate the standard deviation, the mathematical expectation, the variance, and the confidential interval for the results of the phonetic analysis. Here we can see the statement of the experiments. A group of 20 students was formed to conduct the experiments. At the initial stage of the experiments, it was assumed that each student, using a microphone connected to the computer, would record phonograms which sequentially, repeatedly, at the same tempo, pronounced some long English phonemes. The preliminary phonetic analysis of phonograms was performed using the PROAT program. For spectral analysis of the phonograms which a speech signal, using the after-regressive model, the Berg algorithm was used. To enable the comparison of power spectral densities according to the criterion 2, the source speech material was presented in the MEL space of the bank of the corresponding filters, which triangular averaging functions. Here we can see the results of experiment first. The empirical dependencies of the value of the coefficient of reliability of the results of the phonetic analysis delta small on the number of students E whose speech material was used to form the corresponding primary integral phonetic basis XR for phonemes E and A are represented on the figure 1. Potentially, the experiment was oriented to arrange the phonemes of the studied language according to the level of their informatively on the task of identification of the person by voice. Here we represent the experiment 2. The results of the experiments in the metric epsilon are shown on the figure 2. The relative error of recognition of isolated syllables for all sets of databases of phonograms was calculated as the ratio of absolute value of the difference between the number of correctly and incorrectly recognized syllables to the total number of syllables in the corresponding sets of databases of phonemes. Let's generalize the results of experiments. From the empirical results of estimating the dependence of the value of the reliability coefficient of results of phonetic analysis sigma small on the number of speaking students E, shown on the figure 1, it is seen that the hypothesis formulated in the theoretical part of the article about the existence of phonetic data saturation threshold has been empirically confirmed. The received estimation will not be only qualitative but also quantitative, which is especially relevant for information technology of text-dependent authentication of the person by voice, focused on the application in the structure of information system for critical use. Now the conclusions. A model of the process of phonetic analysis of speech signals in the frequency and temporal spaces is highlighted in the article for the first time. The generalization of the spectral characteristics of the studied speech signals is formalized in the represented model as an optimization task of minimizing the functional of relative entropy in contrast of the existing models. The obtained mathematical apparatus made it possible to formulate the metric of qualitative estimation of the quality of phonetic analysis results and to propose an adaptive method of automated phonetic analysis, which an integrated mechanism for counteracting the influence of Gaussian type noise found in the studied speech signals on the final results. Thank you.
Thank you. Please read the question in the chat. Do you see the question?
Not yet. A minute, please. Where is the chat in the Zoom?
Okay, I can read it. How do you see the solution of the problem of minimizing external acoustic disturbances that occur in this work of information systems? The problem of minimizing external acoustic disturbances. How do you solve this problem?
We try to solve this problem by using some knowledges from the information theory. For example, it is the functional of the relative entropy, based on which we can estimate the variance of the sounding of the language units.
Okay, thank you. Due to the schedule, we have go on. Thank you.
Thank you.
Okay, next will be Vyacheslav Goryev and his team, who will be presenter.
Vyacheslav Goryev, I'm here.
Okay, nice to meet you. Please start.
Do you see my screen?
Yes.
Okay.
So excuse me, but we have we see some extra windows.
Now it's a 1 second, please.
This one.
Okay. Okay. And how can I? 1 second, please. Okay, I think these windows will not be critical. So
okay, start please. Okay.
So I will start. So hello, dear colleagues. My name is Vyacheslav Goryev, and this work is made in a collaboration with Professor Alexander Gusev and Professor Valery Kornienko. We are from the Department of Information Security and Telecommunications of the Dnipro University of Technology. And the talk is devoted to fractional Gaussian noise traffic prediction based on the Walsh functions. The outline is as follows. First of all, I'll tell about the motivation of this investigation, then about the Wiener-Hopf integral equation and traffic correlation function, then about the Galerkin method and Walsh functions, then calculation of the integral bracket, description of the results, conclusions, and plans for the future. So the motivation is as follows. The problem of telecommunication traffic prediction is important for information security because the cyber attacks may be detected by comparing the predicted traffic with the actual one. And in a rather simple model, telecommunication traffic may be treated as stationary random process. In particular, I mean the model where the traffic is treated as a fractional Gaussian noise. This model is rather simple one, but it is still used in the literature. And as is known, such simple filter as the Kolmogorov-Wiener one, which is linear and stationary, may be used for forecasting of stationary processes. So it's natural enough to make the idea that this filter may be applied to traffic forecasting. And as is known, in case of rather large amount of data, traffic may be treated as a continuous random process. In such case, the filter weight function is the solution of the Wiener-Hopf integral equation. In fact, this equation is a Fred-Golem equation of the first kind, and it's very hard to obtain its analytical solution. So it's rather interesting to search for an approximate solutions for such an equation. And also it should be stressed that the approach based on the Kolmogorov-Wiener filter is not enough developed in the literature. Our previous paper devoted to the topic of research was presented on the IntelITSIS conference in the previous year, and that paper was devoted to investigation of such a problem on the basis of truncated polynomial expansion method, which is rather popular in the literature. The following method advantages were established: the method convergence and good coincidence for both sides of the Wiener-Hopf integral equation for other many polynomials, but still the method had some drawbacks. In particular, analytical expression for the integral brackets were in fact not applicable in case of rather large number of polynomials. And moreover, we dealt with the problem of the product on very large and very small numbers. And in this paper, we overcome such drawbacks by using the Walsh function instead of the polynomial ones. So the traffic correlation function in the considered model in case where the first exponent is greater than 0.5 is as follows. And in such a case, the Wiener-Hopf integral equation may be rewritten in such simple form, where the input data is given on the time interval from 0 to t capitalized. H is the unknown filter weight function which should be obtained, and Z is the time interval on which the forecast is made. Such an equation may be solved via the Galerkin method, which admits a truncated expansion of the unknown function in an orthogonal set of functions. And the following linear system for equations multiplying the functions f may be obtained, and the quantities g capitalized and b capitalized are expressed in such a forms in terms of the integrals over the functions f. And the polynomial method had the problem that the analytical expression for that integral are in fact not applicable in case of large number of polynomials because of the problem of the product of very large and very small numbers. What about the Walsh functions? In this slide, the standard definition is given. And these functions are step ones, and this idea admits the analytical calculation of the corresponding integrals. And here we do not have the problem of multiplying of very large and very small numbers. And the following analytical results for the free terms and for the integral brackets were obtained. Here W are the components of the corresponding Walsh matrix. They are either 1 or -1. And also we should stress the following properties of the integral brackets, which in particular take place in the case of the use of the Walsh functions. And this property significantly reduce the number of integral brackets for which a straightforward calculation should be needed. And once again, I should stress that no numerical calculations of the integrals is needed if we deal the Galerkin method on the basis of the Walsh functions. So the following calculation of the weight function was done. This function has the following form, and these coefficients were obtained on the basis of such a linear set of equations via the matrix method, and the quantities G and B have the analytical forms, and they were presented on previous slides. And in order to verify this theoretical approach, we should compare the left-hand side and the right-hand side of the considered integral equation. And the Walsh functions are step ones, which leads to the fact that in such approach, the filter weight function is also a step function. And this idea admits the calculation of the left-hand side analytically without numerical calculations of the integrals. And the mean average percentage error of miscoincidence of both parts of the integral equation for approximate obtained solutions was estimated in our paper by the method of trapezoids. And we investigated two sets of parameters and we estimated the corresponding mean average percentage errors for miscoincidence of both parts of integral equation under consideration for these two parameters. As can be seen, the accuracy of the method increases with the number of Walsh functions, and for other many Walsh functions, the map error is less than 0.1%. So the conclusions. The Kolmogorov-Wiener filter for the telecommunication traffic forecasting in a fractional Gaussian noise model is considered in the case where the Hurst exponent is greater than 0.5. And the advantages of the approach based on the Walsh functions in contrast to the polynomial-based approach are the following. The numerical calculation of the integrals is not needed, and the products of very large and very small numbers are absent. And I should stress that at this moment, the work is fully theoretical. So we developed a theoretical approach to the construction of such a rather simple filter. And our plans for the future are, first of all, to apply the developed theoretical approach to practical traffic forecasting. And secondly, to use the proposed approach to other stationary traffic models. And that is all. I am grateful to you for your attention.
Thank you, Vyacheslav. Dear colleagues, do you have any questions?
You can use your algorithms and methods only if the noise is Gaussian, isn't it?
The answer is as follows. We used our algorithm to the concrete traffic models, and we don't know traffic models which are based on non-Gaussian noises. Maybe if such a model will take place, our algorithm maybe will be applied to such a model, but such a question is not investigated at the moment.
Thank you.
Okay, thank you. Thank you, Vyacheslav. Please close your...
Thank you very much.
And the next presenter will be Sergey Lysenko. It's me. I'm happy to make report in our conference. And here we will present the results of our international team from Khmelnytsky, from Poland universities, as well as Czech and Republic. And today I'd like to talk about resilient computer systems development for cyber attack resistance. Today we observe the dynamic growth of cyber attacks amount, and its impact is in every sphere where computer systems are used. Thus, a very strong challenge is to develop new techniques not only to detect the attacks, but also to mitigate, absorb, and resist these attacks. And the very new approach is to develop resilient computer systems which are able to resist to known and unknown attacks. And from the point of view of cybersecurity, computer system resilience is the ability to anticipate, resist, restore, and adapt under the influences caused by the cyber attacks. That's why it's very important to develop the concept of resilient computer system functioning under the cyber attacks. To do this, first of all, I'd like to talk about the main impacts of attacks, background, main idea, and results. So let's start about what the main impacts today of the cyber attacks took from digital threats results. According to it, about 70% of business leaders feel their cybersecurity risks, and its value is increasing greatly, and 70% of breaches were financially motivated. Also, hackers attack every 40 seconds on average 2,000 times a day, and average cost of data breaches almost $4 million. Also, almost more than 90% of malware is delivered by mail, and yesterday our colleague Makowski also said such awful information about it. Also, half of 50% of breaches features hacking, and 28% involve malware, and 37% malicious mailed attach types as simply doc or dot files. And the estimated number of passwords existing today is about 300 billion. And more interesting fact is more than 60% of organizations have experienced an Internet of Things security incident, which is a new fact for today. So what was the background of our techniques proposed, and how we lead to this new concept of resilience? We started almost 10 years ago. I tried to just detect cyber attacks using multi-agent systems. Later, we improved our techniques involving DNS-based techniques, and during previously years, we involved self-adaptive ideas to just detect cyber attacks. But now it's a problem because the problem is because it's a lack of efficiency, not only to detect, but we have to involve more new aspects. So let's talk about resilience. Cyber resilience is the ability of a system or organization to enable some acceleration by preparing for, responding to, and recovering from cyber threats. And cyber resilience organization can adapt to known or unknown crises, threats, advertises, and challenges. So how must be resilient computing system? So the resilient functioning concept involves such main things that such computer system must be prepared and protected, able to detect, able to respond, be adaptive, and be recoverable. To do this, 5 concepts, 5 aims we have to prepare some measures to do this. So, taking account of previous concepts, we have to take a look at operational cycle of the resilient computer system under cyber attacks. Of course, we have to monitor such system and to adopt needed changes according to attack. And during this cycle, when system is protected after it was attacked, we have to adopt some needed measures in order to not only absorb response, but also recovery and include some adaptation techniques in order to be stronger before next attack. So to do this, to build such resilient system, we have to take into account, of course, start from the time intervals which characterize a system resilience, because we have known when the attack was started and one system was degrading, and later also we have taken into account not only system degradation interval, but also system recovery interval as well. Also, we have taken into account requirements to the resilient computer system and the cyber attacks. Following this, each state of computer system is characterized by set of parameters such as system parameters, system requirements, and maybe some environment parameters, which may indicate whether it is increasing or decreasing some values, which may indicate that system is degrading or recovering. Also, while monitoring system and to construct resilient system, we have to adopt a set of mechanisms which are to be applied depending on the state where the system is occurring at the moment. And so measures are very important. And let's take a look at stages of the resilient computer system. First is its preparation, and of course we have to make a set of preparatory measures in order to prevent a possible cyber attacks. And it includes not only measures of just architectural components, setting up, but also configure connections between system components, adjust segmentation maybe of system, ensure monitoring, and prepare a set of security scenarios which must be applied in the situation of cyber attack. And of course, measures which will ensure the system information backup execution. The next stage is protection, and protection aspects. It's very important because we have to understand and to evaluate the cyber risk by analyzing and simulating cyber attacks, maybe identifying and eliminating known vulnerabilities in our computer system, maybe operating system, maybe networks, and so on. We have to rise up awareness of the sign of no cyber attacks threats and understand how to recognize them, and of course appropriate backup and restore strategies. The next stage, it's a preparation, and it involves the development and implementation set of methods which the goal is to protect computer system infrastructure and minimize the likelihood that an attack can be successful. And if that was happening, we have the ability to respond quickly and reduce the damage. The main stage is detection, because it's entry point to stop the degradation of the computer system. And we have to take into account two kinds of methods concerning not only host method detecting, but also networking. So we have to monitor not only what is going on inside the computer system, but also in the network environment. The next stage, it's absorption, and to absorb some attack, we have to reflect some current performance of the system, and if we saw some destructive action, we have indicate a value, and to know what is performance at the moment. If we were attacked, we have to respond, and resilient computer system has contained a set of methods which are to be activated in order to mitigate the impact of the attack. And now the next stage, it's a recovery. It's a final and the most important stage. When the system is attacked, we have to recovery. And adaptation also, we have to absorb knowledge about new attacks, and when the next attack will be raised, we have to be ready for this. Okay, as example, I'm talking about the resilient system. We have developed a bot grabber system. It's a tool which is able to detect and produce some cybersecurity scenarios, taking account information what attack exactly was detected. And here you can see its abilities and its architecture. And as example, in this presentation, we presented man-in-the-middle attack. It's a hijacking type of attack, and it's trying to insert some information between client and server. And we tried to describe the situation, and not only this bot grabber system is able to detect, but also to produce some measures in order to mitigate this attack. And also here we can see the metric of resilience, which take into account the attack rapidity, reconfiguration stage rapidity, value of performance system of the degradation system performance, and ability to apply of security scenario. And according to this, we obtained some results because we tried to attack hosts, servers, routers for these experiments. And here we can see some results in this scope. Okay, and there's a discussion to make this technique more cute, more efficient. Of course, we have to involve maybe some machine learning new algorithm in order to detect, add to system features which are relevant to the text, and provide and use the security scenario. Thank you for attention. I tried to be as quick as it's possible. Maybe you have questions because we have a few time. Thank you for your attention.
Thank you, Sergey. College, please, question.
Do you
May I ask a question?
Yes, please.
Yeah. Okay. So, does your approach detect phishing, cyber phishing? Have you considered this type of cyber attack?
Yes, of course, it's a very important and interesting type of cyber attacks, because during last months I tried to buy some issues on the internet and using some service, and I saw that I was almost hackers attacked by phishing service, and but having some ability to recognize it, I didn't was hacked. But our system about Grabber also involves this possibility. Thank you.
Thank you.
Okay, who want to ask a question?
So, do you take into account in your research that the cybergrid may have a complex character, for example, in different stages consist to each other?
You are talking about what encryption or
The cyber attack may consist of different stages.
I see. Yes, of course, because, for example, botnets may execute, for example, part of botnet may be installed on the computer system, and it may be executed months later. Yes, so and its stages may be in time where we will be divided in time greatly. So yes, we have to monitor and to combine each parts of its stages into one later and to make a decision. Yes, of course, it's very important. Thank you.
Thank you.
Thank you, Sergey.
Well, okay, colleagues, let's continue. And the next presenter will be Andrei Nichiporuk and its team. Please, Andrei.
Okay, share my screen. Do you see my screen?
Yes.
Yes. Okay. Hello, dear present. I'm going to present you the report on the topic a system for detection anomalies and identifying smart home devices using collective communication. The report is presented by Andrei Nichiporuk, Associate Professor of Computer Engineering and System Programming, Department of Khmelnytsky National University. For a considerable period of time, humanity gets the benefit from the use of smart devices connected to a network to improve and automate our life. Smart homes, healthcare system, automation system, and industrial Internet of Things are prime examples of systems based on the network of connected smart device under the control of microcontrollers. The next step in the evolution of such system is their integration into social networks. For example, the integration of smart homes into social network forms a higher hierarchical level of their interaction, which produce new opportunities and benefits, in particular in terms of management, storage, and processing of information, improving end-user services, prevention and collective response to emergencies and events. In terms of security, our research focused on benefiting from the integration of smart homes into a social network in terms of improving the security of both a single smart home and the entire social network of combined smart homes. The most important reason why criminals choose to attack IIoT device, in particular smart homes device, are their constant availability on the internet, limited computing capabilities, vulnerabilities related to authorization, authentication device on the network, heterogeneity of the device and their communication environment, vulnerabilities in web interface, lack of proper attention from end user. Yes, put and forget, leave standard parameters of such device. So we propose a system for detection anomalies and identifying smart home device using collective communication. The implementation of the system for detection anomalies and identifying device in smart homes is based on monitoring of network traffic and construction of profiles of smart device that are presented in the network. Based on this, a wide list of allowed profiles of devices operation in the cluster is formed. A key feature of the system is the communication of clusters with each other to exchange information about available profiles of smart devices. The generalist functional scheme of the system for detection anomalies and identifying device in smart homes are given in slide. The system of detection of anomalies and identification of device is placed in the internal network of a smart home and consists of the following modules: network traffic monitoring, detection of anomalies in network behavior, identification and decision-making module, PDML conversion module, feature extraction module, and classification module. Information about available devices in smart home is stored in the wide list of smart device profiles. It is assumed that smart homes are connected to a social network. The identification and decision-making model organizes the operation of the system in three modes. Monitoring, the first one, monitoring of the network traffic and detection anomalies, search for device profiles in the cluster, and the last one is search for profile in other clusters in social network. In the first mode, abnormal behavior in the network traffic is tracked. If abnormal behavior is detected, then the transition of system to the second mode is carried out, in which the classification of network traffic and identification of smart devices is performed. If, as a result of classification, it was possible to match a suspicious profile to one of profiles D with index I of smart device in smart home, then the system returns to the first regular mode of operation. Otherwise, if the specified sequence of packets in the cluster C with index J is not matches to one of the profiles D with index I, the threshold value is not exceeded. The sequence of packets is denoted as unknown sequence of packets, and the system have been transmission into third mode. This mode involves requesting to other clusters in order to check the sequence of packets, their profiles, received in the cluster C with index J, with whitelist in each cluster in the social networks. To form conclusion, the model of identification and decision-making in the cluster which initiate the request to other clusters from the results of the response of all clusters forms a list in which each element is entry type of device in the founded cluster or unknown sequence of packets. The request of the system C with index J in cluster Cj for generated list is calculated as presented in the slide form equation 1, which is presented the ratio between found device type and unknown sequence of packets. If the result of the system C with index J is greater than 1, then the sequence of packets that form a suspicious profile could be attributed to one of the profiles of smart devices DE with index I in one of the clusters in the social network. In order to check the presence of profile in the whitelist, the classification model is used, which is based on the random forest algorithm. In order to obtain feature for the classification, the entry fixed period of traffic monitoring T was divided into time intervals T small with index I, each of which consists of a set of sessions S. Then, within each interval, a set of feature is obtained that describe the behavior of the packet from given that specifies of the operation of smart device. As a result of the classifier for each time interval, which is represented by the vector f, probability vector is obtained, each element of which determines the belonging of the packet flow to a smart device D I in the cluster C J. A packet sequence is considered to belong to one of the smart device if probability of belonging of the packet flow to a smart device D with index I is greater or equal delta, where delta is probability threshold. The final choice of a smart device D with index I in the cluster C with index J for the entry monitoring period is defined as a model value from all intervals T small with index I. Thus, the while list of profiles contained in each cluster is in fact trained classifier models and contain a marked set of features for a given monitoring period and given time intervals. In order to form a profile of each device, the following characteristic of network traffic we consider they are presented on a slide. Next, we conduct several experiments. We built two clusters with which simulates the two IoT network, which each of which contains some type of IoT devices. You can see in this slide, yes, two clusters and devices that are placed in these clusters. The first experiment involved determining the efficiency of identifying profiles of smart devices that are presented in both the white list of profiles and outside this list locally on the same cluster. We use cluster number 1 to check this. In order to simulate abnormal activity, a total of 4 series of experiments were performed, in each of which the classifier was trained on the date that included only 3 of the 4 smart devices. In each experiment, only 3 smart devices were represented in the white list of profiles. The result of experiments showed poorly quite high results. In particular, the highest efficiency was obtained in the first experiment, in the white list of which there was no smart column Amazon Echo. In this experiment, 98% of the network traffic station corresponding to the Belkin-Lemon motion sensor were identified as belonging to it. In the second experiment, the accuracy of the entry system was tested in sequential execution of the second and third modes of proposed system. The purpose of the experiment was to check whether the system will be able to identify a device if this device is not in one cluster, but it is in other cluster. For this purpose, two clusters were involved and white list of device profiles presented in it were created. 3 series of experiments were performed to identify the profiles of Nest smoke sensor, TP-Link camera, and lighting scale in cluster 1. The white list of which did not contain this smart device. The result of experiment are presented on the slide. In this experiment, the false positives level.
Andrei, we have time limitation.
It's 1 minute, please. In this experiment, the false positives level determines the number of sessions belonging to the test smart device E, F, and G, labeled which were assigned to one of the device marked as A, B, C, and D. According to the result of experiments, the overall accuracy of system obtained at the level at 19.7, which an average level of type first errors of 5.9%. Thank you for attention. Please, maybe you have question.
Thank you, Andrei. Maybe only one question because we have time limitation.
So sorry.
Okay, let's move on. So the next presenter will be from Kazakhstan, Gulmira Shakhmetova and her team. Are you ready?
Hello, yes, I'm ready, I'm here.
Greetings from Ukraine.
Did you hear my presentation?
Yes, we see you, yes.
Okay. Good day, everyone. My name is Gulmira Shakhmetova. I am senior lecturer in Information Security Department of Eurasian National University, Kazakhstan, Nur-Sultan. And today I'm glad to be in your international workshop. And I'm going to present my report, Application of Pseudo-Memory Finite Automata for Informational Inscription. Contents of my presentation, its motivation and objectives of the research. Also, I will give some definition of pseudo-memory finite automata and explain basic algorithms of FAUX and conclusion and future work. Nowadays, the development of informational technologies bring to cryptologists not only opportunities to solve the most difficult cryptology classical task, also they give capacity to hack well-known crypto system. Therefore, applying other areas of mathematical for modification of informational security method is a relevant task of research in cryptography. For theory of automata was considered as an alternative model for creating high-speed crypto system. In the theory of numbers, a large number can always be decomposed into simple factors for which the order of their mutual arrangement in the product is not important. However, in the theory of finite automata, the order of arrangement of primitive automata in the composition is important. In other words, the composition of finite automata does not have the property of commutativity. Consequently, the problem of decomposition of compound finite automata into primitive components is as difficult as the factorization of the product of two large numbers. For that reason, this property allows creating ultra-reliable informational security system, which confirms the relevance and importance of creating crypto system based on finite automata. In this paper, we survey existing work and concept of finite automata crypto system with OpenK, its background and general algorithm of inscription and description process. Also, we were interested in the pseudo-memory finite automata that were used in FAPS version 4. For a better understanding of the application of this type of finite automata in cryptography, we demonstrate an example of the application for inscription and description of information. A finite automata is a mathematical abstract device that operates in discrete automata time. The basic concept of asymmetric cryptosystem based on finite automata is the use of a weakly invertible automata with delay tau, which allow reproduction of an input sequence of characters by initial internal state and an output sequence of characters. How you can see in this slide, formal definition of weakly invertible automata with delay tau and a definition of inverse automata with delay tau. As mentioned earlier, the considered type of automata is a pseudo-memory finite automata, which is defined in this slide. In the FARC cryptosystem, the public key is the composition of weak invertible finite automata, whereas the private key contains their inverse automata. This cryptosystem can be used not only to inscript and decrypt information, but also to sign and authenticate transmitted messages. Next, I will consider the basic algorithm of FAPS using the example of an automaton with pseudo-memory. In the first step, need to generate two invertible finite automata, M0 and M1. For example, we take two linear pseudo-memory automata over a finite field F and take the parameters MLN equal 3, in which W, X, and Y are the vector columns of dimension ML equal 3 respectively. Let M1 be a linear automata with pseudo-memory of order 400 with delay tau 0 equal 1, and M0 be a linear automata with pseudo-memory of order 110 with delay tau 1 equals 1. M1 and M0 are defined as follow in this slide, where U and W, it's pseudo-memory of this automata. In for automata 0, M0, Z at output memory and Y at input memory. For automata M1, X at input memory. For function G0 and G1, operation dot means component-wise multiplication of vector elements. Matrices for this automata constructed by RA-1, RB-1 transformation rules. On a second step, generate two inverse of automata M0 and M1. Inverse automata M0 star and M1 star are constructed according to the rules of RA-RB transformation. The inverse transducer are defined as shown on this slide. On third step, the composition of two invertible automata M1 and M0 is constructed. Its position C dash. For our example, we construct the composition of these two automata C dash with delay tau equal to the sum of tau 0 and tau 1. It means it's equal to. Also, in this step, we select an attribute arbitrary initial state of the automata C dash, which will be used in the beginning of inscription. And the fourth step, the part necessary for description are determined. Its state as 1D out and state as 0D out. And last step, the user public key is composite. It's open public key. It's composition of two invertible automata M1 and M0, also in initial state S and delay tau of this composition. The user's private key consists of two inverse of automata M0 star and M1 star, else also two state S1D out and S0D out, and two delays tau1 and tau0. For inscription process, user B adds attributary characters of length x and plus tau to the end of the given plain text and calculates the ciphertext using the public key. Then send it to user A. For our example, since the automata C' has delay 2, we need to append the plain text with two arbitrary chosen symbols. And after that, calculate the ciphertext using by our open key. Description process consists two parts. In the first step of description, we use inverse of automata M0 star and state S0D out. In the second step of description, we use inverse of automata M1 and state S1D out. After all action, we will get our plain text. FABs have some advantages over widely used wide used asymmetric cryptosystem. For instance, their inscription speed faster than RCS, as their algorithm is based only on logical operation. In addition, the FABs cryptosystem can be attributed to stream inscription, which give it an advantages in the inscripting and decrypting speed, because plain text does not divide it into blocks. The disadvantages of the cryptosystem includes the large size of public key, as well as the problem of generating random and equally probable keys, since the key space of the FABs algorithm is specified by the description of the properties of its elements. And in conclusion, summing up, it can be noted that the use of high-speed automata allows creating a strong asymmetric cryptosystem based on finite automata with high inscription speed. However, using big parameters in cryptosystem will increase the size of public keys. Thereby, finite automata cryptosystem with size of public key within acceptable limits could be used as part of combinatory cryptosystem, which consists of several inscription algorithms and models. An approach to design a cryptographic algorithm using finite automata with pseudo-memory is analyzed, which in construct to existing algorithms make it possible to increase the security of the designed asymmetric cryptosystem based on finite automata. In the future, we are planning to develop software models for generating pair of cryptographic keys for an asymmetric cryptosystem based on finite automata with pseudo-memory. Thank you for your attention.
Thank you, Gulmira. Colleagues, we have no more time. Maybe one small question, please.
Yeah, may I ask? Have you compared your mathematical tools with others for encrypting or decrypting? So what is the main advantage of your approach?
Now we just survey the existing works, and we work on for doing this compare with other mathematical models.
And do you think that
Okay,
your one is the best one? Okay, thank you.
Thank you for.
Okay.
Oh, okay.
Okay, the last but not the least presenter, Statsuk Mykola, is he here? No. Maybe I'll call him. Okay, colleagues, due to some communication problem, so our section is ended for today. Thank you, all of you. All presentations were very interesting and exciting. So we will meet due to schedule. Thank you. See you. Bye-bye.
Thank you very much.
Bye-bye.
Bye.
Thank you.